Okay, so I'm Daniel, co-founder of the Space Computer Project, and we'll take you through an interesting journey. There will be some aspect of the motivation for what we actually are building, and then we'll also get into the deep dive of the technical details of how we're actually implementing what the space computer is. So a brief history, we started with the Big Bang some billion years ago or something. And since then, there was the chaotic planetary scale tohu vavohu, and all kind of organisms gradually formed. Initially, I think algae and some other organism eventually crawled out of the water. Fast forward a little bit, we became apes. I know some people still refer to us as apes. From that, the hunter-gatherers that already started being a little bit more strategic, and then the early cavemen, and the first formation of villages, and essentially the kind of buds of human society and civilization. And then with that, we were able to also get to the very early version of money, with shells and rocks as a medium of exchange and store of value. And eventually establishing the global trade routes. So that would have been the Silk Road or the ships that sail on the sea otherwise, with trading outposts here and there. The invention of the banking system, then the stock exchanges, venture capital systems, all of that actually still runs today. It's already existed for a while. And maybe taking a tangent on a different evolution. So if we're looking at compute, starting from concepts that were initially philosophical or the initial Greek math, and then taking it into a little bit more pragmatic and useful forms beyond only things that we can do ad hoc, we came up with task-specific computers. Task-specific, so they were basically fit for certain unique applications, but not for any application. Then came the brilliant Alan Turing that I'm sure many of you know. Alan Turing was the invention of the Turing compute machine, which essentially is a general purpose computer. The motivation back then was to crack the Enigma code and to defeat Nazi Germany in the Second World War. But the interesting thing is that beyond only solving that one problem, Turing was a nerd. And as a nerd, his motivation was to bring complete new innovation, which was a general purpose compute machine. Like, he did not predict that we'll end up with applications like Google or Uber or Ethereum or Bitcoin running on a global scale computer. And then to scale the computer or compute systems, the invention of the solid-state transistor came. So essentially moving from mechanical moving parts to solid-state silicon-based chips that were then miniaturized, and to this day we're just keep grinding at developing new nodes, semiconductor industry, and that's kind of how we scale compute. And then as things advanced, we came with the high-level programming languages, and then normal people could start writing scripts, oftentimes in a human-readable language, and they don't need to necessarily know all the machine-level operations that actually happen underlying silicon chips. And eventually graphic user interfaces, which is, user-friendly for the ape level, which is going back to where we started. And now we take a little bit of a zoom in on the internet. So if we started with the Web 1.0 in the early days, the 90s or so, that it became a household thing. We had Netscape and MIRC and the things that were still relatively peer-to-peer. There was a little bit less conversation about engagement optimization, call to action, and all the data harvesting that later came with Web 2.0. So Web 2.0, we moved from a more emergent and peer-to-peer-like to a more user-server architecture. So that would be all the centralized big tech companies that give fantastic service and commercialize it, but then at the same time we are quite well aware of the trade-offs that we have with privacy breaches and our data basically being monetized by somebody else, and we don't see so much of it on our own. And then the introduction or the evolution into the Web3 ecosystem, which is kind of a return or a peer-to-peer variant of Web2 in a way, and taking a little bit of a deeper look into it. So if we think about civilizational technology and the place for crypto as civilizational technology, the first breakthrough was the Bitcoin blockchain. And Bitcoin was intended as peer-to-peer electronic cash system, so a payment system, which ended up not really functioning that way for various reasons that I'm sure some of you are aware, some less, but more landed on the use case of digital gold. And the Bitcoin blockchain was somewhat akin to a task-specific distributed computer, just like before the general purpose computer. And that's a part of what the innovation of Ethereum was, that it essentially expanded the design space with the introduction of the world computer, essentially a general purpose smart contract platform. And that enabled all the many use cases that we are thinking of today, DeFi and DAOs and NFTs and meme coins and essentially, you know, an open canvas. But if we think about it, since Ethereum, there hasn't been something that was fundamentally new. There was always like, this is cheaper or faster or something else. Like, no offense for Solana friends, and I really respect it, but like if you actually think about it, there's really no novelty since Ethereum. So the question is that what we are all about? Like just kind of a dot in the universe, and like, is there a place here to expand? And now we'll go to another little tour with the space frontier. So space has been hot for a while, then dwindled, and now we've been really entering a re-accelerated space phase. And what we're seeing is that in the last 2 years alone, there's been more launches of satellites into orbit than in the previous century combined. Like the whole moon missions in the Cold War, etc., right? That was kind of minuscule number compared to what we see launch into orbit nowadays. And we're seeing innovations like the upcoming Starship and other competitors that are looking to increase the volume of the payload to hundreds of magnitude, basically, compared to what we have today. So essentially, we see that there is a new golden age of space, and we can start thinking about new applications beyond what we've seen until now. So what we want to do is build a blockchain in space. And why? Until now, we were thinking about space as something that is really at the like state level or like very big enterprises level innovation. That's the classic like imaging, location services with GPS, weather forecasting, communication. All these are great. But what if it's so easy to launch satellites that we can start thinking about completely new things? So the physical isolation in space gives us a really unique advantage here, because essentially what we see is that every node that exists on a satellite with the right configuration can serve as a tamper-proof environment, like a trusted execution environment aboard a satellite. So that's kind of the quest of like, are we in that place now that we can start thinking about space as a real environment to iterate and try and build meaningful and high security guarantees things for crypto to really gain adoption? And that's what we're building with Space Computer, essentially a distributed compute that expand the world computer concept into the space. And with that, exactly on the architecture and how we're implementing, I'll pass it on to Filip, my co-founder.
Great, thanks Daniel. Thank you for being here. And as Daniel was mentioning, the vision is very optimistic. We have a lot of work ahead of us, and I will try to show how we actually plan to unroll it step by step to make sure that Space Computer can become a reality. Important to mention that during the great intro, we are building on the shoulder of giants with respect to the achievements that enabled us to even think about achieving what we want to do. And I will try to showcase on how we plan to combine all of the individual components together to make it a reality. So firstly, as Daniel was mentioning, what is actually space computer? So we plan to be a new, robust layer 1 in space. The motivation is clear, physical isolation, try to not only focus on the on-Earth use cases, but we see a potential of future space use cases, where individual satellite itself will be providing trusted execution environment capabilities. For those that are not familiar with the concept of TEEs, you can think of it like a confidential compute that can be run on a in a malicious environment where either the host or the hypervisor can be malicious. And each of the satellite itself can actually provide the SpaceTEE capabilities due to the onboard trusted execution environment provided by the hardware, but also have strengthened threat model due to the aspect of the physical isolation. And of course, in order to make it a whole and full-fledged infrastructure, we cannot only rely on a single satellite, but we need a network and constellation of satellites that will be providing the robust layer 1 infrastructure, combining the individual components together. And of course, as a part of the use cases we envision is a full aspect of economy in space, where we definitely start to see that more and more orchestration and settlement can be happening directly in space without the need of actually communicating with the on-Earth components as well. So where we currently stand as of now is that we have a single satellite that already enables us quite a few capabilities. And in order to interact with the space infrastructure, we are using our gateway called OrbitPort, where OrbitPort itself is an infrastructure that we currently operate and is able to communicate with our infrastructure in space. As of now, we envision that this is going to stay like that. We are aiming on making it more trust minimized, as I will be highlighting on the other slides. And aspects of the OrbitPort will be extending to accommodate for future use cases when it comes to interaction with the aspect itself. As of now, we support the first use case, which is a generation of a cosmic true random number generator that can be already fetched and used in use cases on Earth. But in the future, we want to expand it to other applications, such as custodial wallet and more. And of course, on the aspects of the user, we want to provide similar capabilities by interacting with the infrastructure, where the Earth users should be able to interact and send the transactions either through OrbitPort or other type of components to make sure that their transactions or others will be later on communicating with the respective hardware in space. And at a similar time, since we'll be relying on a different communication media, either Starlink, Iridium, or many others, we also think of it like a dedicated backbone or backup links that can be using different type of communications than we are used to from traditional internet aspects as well. Since we are envisioning to scale our system, we don't only want to provide the L1 capabilities that will be providing the aspects of the robustness and the security for the settlement. But of course, we need to scale through layer 2 solutions on Earth, since we are in a medium to short term, definitely communication and computation constraints. And for that, we are getting a lot of inspiration from the layer 2 solutions from the Ethereum ecosystem that can be deployed either in the optimistic or zk rollup setting and later on interact with the L1 itself. But of course, what we are also interested is to provide some form of novelty with respect to providing additional capabilities to the L2s on Earth as well, irrespective of which layer they are settling. So on that front, we definitely see several use cases that can be relevant either in the new cryptographic primitive in the direction of SpaceTEE and many others, providing communication and computation resilience to the users on Earth itself. Of course, the main assumption for this type of solution is that we will have a full-fledged constellation, which is currently something we are actively working on, and I will be providing also at the end a short roadmap on what are the next steps for us moving forward. Diving a bit more into the current use case and actually how the architecture itself look like with respect to OrbitPort, what is happening under the hood. So we see ourselves mainly as a software company with respect to designing and providing the protocol that later on others can interact with. And for that, we are partnering with different type of infrastructure providers that can provide us the hardware. But of course, we also want to have the hardware specification and the requirements under our control and provide them and communicate with individual partners that can later on launch the equipment for us. One of those providers is currently Aptos Orbital that is already providing us with a satellite we are communicating and using, which currently provides us the access to the randomness from space. And looking into the details on how does the interaction from the user perspective on Earth looks like is that they are communicating with the gateway called OrbitPort to fetch the relevant information and provide it to the users on Earth. As of now, we are able to provide you with integrity, meaning that you know that the data that you are receiving on Earth are coming from the respective infrastructure, but we plan to also expand it in the upcoming weeks by providing end-to-end confidentiality, meaning that you actually encrypt the data in the space, and you as an end user get these data on Earth in a full confidential fashion in the end-to-end flow as well. So this is definitely something that we are actively working on. And as a part of the end-to-end flow, we are also actually looking into the applications and use cases of TEs on Earth that can provide us this trust minimized setting where actually orbit port itself can provide and be a trust minimized component with respect to the communication between the user on Earth and the infrastructure in space. As mentioned already, we are now looking into the aspect of randomness that can be used in several use cases, where we are also looking into some aspects of innovation on how to integrate this randomness into cryptographic or consensus protocols, for example, in the direction of peer selection, consensus leader election, or some cryptographic protocols, for example, threshold signing, that are relying on randomness. That could be actually getting the randomness, true randomness, especially important from space itself. Looking at the roadmap, orbit port is the enabler of many of the use cases we envision. As mentioned, as of now, we have the aspect of the CTRNG, but we envision many other use cases beyond. Either if you look at the secure vault or space vaults, when you think of it, that can provide custody by running your key generation process among multiple satellites, where each of them is also having the T capabilities. That can be also very interesting for aspects of DAO, where we have certain guardians that can be definitely relevant. Of course, for the future DeFi applications, if you want to have a location where you can store your collateral in a secure fashion. But of course, in general, the trend is towards programmable cryptography. So we are planning to provide a SDK tooling to users that can later on play and interact with the capabilities provided by the L1 and the individual security services. And the future looking is definitely towards a celestial compute marketplace where you can do and have more autonomy in space among individual providers as well. With that in mind, we try to outline the roadmap where the immediate next step after we have published our vision, blue paper, last year in November, is to now really nail down the specification of our consensus and other components, where as of now we know that we plan to be EVM compatible with respect to the smart contract capability platform aspects, and we want to now finalize the aspects on how the network itself will look like with respect to the peer-to-peer layer, consensus, and how can we all combine these individual components together, as which will be outlined in the white paper coming out in the upcoming months. And moving forward, we definitely see some interesting use cases, either for key management, as I was mentioning, in the direction of custodial wallets, but we definitely see key management being a problem in many other settings, even within the ecosystem for proper key management services themselves. Since we see that already as of now we have an access to a single node, we definitely want to expand on the many proof of concept implementation that can be done on a single node itself. For example, by deploying a full-fledged client providing execution and consensus itself combined, where we can actually already deploy the smart contracts. And later on, start to look into the aspects of proof generation for aspect of verifiability, but also for the aspects of finding a way on what is the cost our infrastructure can handle, and look beyond also into the L2s, AVSs, and similar for scaling on Earth, because the users on Earth as a part of the journey should be interacting with the L2 components, and later on get settled on the L1 itself. And of course, the ultimate goal is to provide a full-fledged L1 constellation, where we will have multiple nodes, multiple satellites in our case, that will be each of them having full-fledged SpaceTEE capabilities, and will be able to reach consensus on a confidential platform itself. So we are a space computer. We already have available for public demo the aspect on how can we interact with the CTRNG. And if you're interested, feel free to follow up and also catch us up. Daniel, Yangwo, and others will be here throughout the whole week, and we'll be definitely happy to answer some of your questions. Thank you very much.
I just wonder how do you test that the TRNG in the satellite is still functional, and how do you even know that a TRNG is broken or is actually still giving you supposedly true randomness?
Mm-hmm. So we are currently looking into the aspects on actually how to verify it. So there are like good test suits from NIST, for example, that you can actually use to verify the entropy of the random numbers you are getting. And of course, we have to make sure that we'll be doing these regular checkups because it can keep changing. But the general assumption is due to the fact that the satellites are running in space, you are having the cosmic radiation that actually is affecting your random number generator. The fundamental assumption is that because of that, we are able to get that random number generator. But definitely, there is some more work to make sure that we can continuously verify that actually this is the case, because maybe due to the radiation itself, maybe some components of the chip that is actually later on providing and fetching the noise itself can get compromised. So definitely it's a continuous process. For now, it's just the initial idea that if we have it, what can be done with it. So it's not far, it's a little bit farther from making it as a production-ready solution, but definitely as a part of exercise is definitely something that we see as a good potential on how to make it possible. And the fundamental aspects are in place. We just have to now make sure that we walk the talk and put it into a production.
One last question.
Yeah, I think it's a really cool project, by the way. Thanks for coming. I actually came to the previous talk and stayed because it looked cool. Look, my opinion of Web3 is that it doesn't matter how fancy we get with the blockchains or the dApps or anything, the infrastructure's screwed. You know, it's all Amazon, AWS, all this stuff. It's all centralized. So it's cool that we're trying to take it off planet. So my question is more around how diverse are satellite providers? I know nothing about that. So if we get up there in space, is it all just Elon Musk owns the whole thing? Are there 5, 6, 10, 100 different satellite providers? If you could help us understand that.
Yeah, it's a great question. I think that's the vision we see that, as Daniel was mentioning, and now it's a perfect timing because we see that, fortunately and unfortunately, many of the aspects of space are very relevant for many governments. So they actually try to really push on the frontier on how can we decentralize the front of having our own manufacturing capabilities, having our own capabilities on actually providing communication. So that way, of course, we can support Starlink, we can support Iridium. All of these are operating in different jurisdiction as well. And of course, we see that other countries or continents are trying to provide different communication settings as well. So definitely on that part, we see that due to the nature of the space race becoming now, I would say, very prominent due to the capabilities and the control over it that individual players want to have. It's also something that enables us to actually have decentralized consideration. So with respect to the infrastructure we want to build, we want to have this stuff as a part of the requirement, meaning that we are able to communicate with different providers, so that way we cannot just like get censored on a single one. But of course, this is the end goal that we envision. We'll be taking individual steps to maybe at the beginning be more centralized on the front, but definitely looking into the future and decentralizing all of the individual components before we can go live.
It's very competitive, so you have more and more providers. Like initially, yeah, like everyone's relying currently on Starlink on SpaceX for launches. But Blue Origin is becoming operational. I think everyone is, like in Europe, people are concerned about depending too much on Elon, so they're starting to encourage the industry here. China, obviously, so it's like, it's growing, it's maturing slowly. But yeah, it's like at the moment, it's still not as diverse as you would imagine that you'd want, but yeah.
Thank you so much for your presentation.
Thank you very much.